video tutorial on Splines Part 1. Okay, this is part of a course at VCU, but anybody can use it. All right, so what is a spline? And here I'm going to focus on linear splines, just so you're aware. If you're familiar with splines, you'll probably yell at me. But if I look at the word spline, I see the word line. It's just a generalizable line, and it allows us to fit data better than we would normally fit, than basically a straight line that you would use with simple linear regression. Okay, so here's some data. Simple data set, looks like a line will go right through that thing, and it should fit fine, right? So we can give it a straight line fit. And if just for review, what does a straight line look like? We're going to have a y as dependent variable, x independent variable. A linear relationship is defined as y equals beta 0 plus beta 1x. If you're a statistician, you'll put epsilon on the end here. I'm not doing that just to make the math easier. All right, so we have an intercept, we have the slope, and we can use the computer to fit this, and it will use least squares. And if we're in R, it'll use the LM function. All right, so this is what this line would look like if we fit it to our data. And here's the equation of the line that we got out of LM if you happen to go through and do this. Now, notice you say, well, that line fits pretty well. I don't think it does. Look, there's a huge gap here and a huge gap here. It looks like the data comes down, goes up, and then comes down, not just in a straight line. So what if we could do that? What if we could do 3 lines at once? That would make a much better fit. Comes down, goes up, comes down. Looks much better than that line. Okay, so this is our goal. We want to fit 3 lines instead of just 1. And this is where this generalizable line comes in. This is a line, this is a line, this is a line. Is it a straight line? No. Is it a line? It depends on your definition of a line. All right, so this is basically what we want. We want 1 line if we're below 1 point. We want another line if we're between 2 points. And we want another line if we're bigger than some number, right? We want 1 line if we're below some number. We want this line if we're between 2 numbers. And we want this line if we're bigger than the last number. That's basically what this says. Okay, now, it looks harder than it actually is. The key is this function here, okay? So this is x minus k with a little plus in the subscript. It's 0 if x is less than k, and it's x minus k if x is greater than k. We'll see how we make this work in the algebra. Okay, so very simple case. We want 2 lines. Okay, this is going to give us 2 lines, and just by playing with the algebra a little bit, we can see how this works. We have beta 0 plus beta 1 xi. I've added this term on to my regression. I've added another variable in here that is derived from my previous variable. And if I do the math on this, well, if x is less than 10, this thing is 0. So it's not there. If x is greater than 10, then it exists, but I don't need the plus sign because I know it's going to be a positive number because x is greater than 10. All right, so again, this carries forward. Just plug this beta 2 through distributive property, and then regroup. We regroup together. The beta 2 does not have an x across, beta 2 times 10 does not have an x attached to it, nor does beta 0, so that's my intercept. Beta 1 and beta 2 have an x attached to it, so that is my new slope. Easy enough. Okay, so this is how we could rewrite this, and look, we end up with 2 lines if we just substitute this in. If we substitute beta 3 for beta 0 minus 10 beta 2, and beta 4 equals beta 1 plus beta 2, we get 2 lines from this one. They're equivalent. All right, if we go to 3, we're going to create 2 new variables using our little function here. We're going to have 2 different breakpoints, which is what we said before. We're going to have 1 line up to 1 number, then another line between 2 numbers, then another line after it. Okay, so here we go. This is what this is going to produce if we rearrange this and go through the algebra. I'm purposely not going through the algebra for you. And if you want to, this is how you could break this out, right? Alpha 1, alpha 2, alpha 3, and this is how they're defined, and we get just this picture back here. But you can see it's a line, another line, and another line. And that's what I'm trying to get across today. It's just a generalization of lines. And we can do this pretty easily with the algebra. So we can fit this model in using multiple linear regression. It's pretty easy. We have beta 0, beta 1, beta 2.